Every skyscraper, every bridge, every dam, every airplane exists because someone believed it would never fail. Millions of calculations, thousands of engineers, years of planning, and billions of dollars, all designed to prevent one thing: failure. But history has proven something terrifying. Sometimes, the greatest engineering disasters don't happen because of massive explosions or impossible natural disasters. Sometimes, they begin with one tiny mistake, one overlooked calculation, one ignored warning, one decision that nobody questioned. And within seconds, entire bridges collapse, cities lose power, buildings sink into the ground, thousands of lives change forever. Today, we're uncovering the biggest engineering failures ever made. Stories so unbelievable, they almost sound like fiction, but every one of them actually happened. Number 5. The bridge that destroyed itself, Washington State. Construction of the Tacoma Narrows Bridge was finally complete. It was considered one of the greatest engineering achievements of its time. Stretching over 800 meters, it connected communities, created jobs, and symbolized modern engineering. People came from all over America just to see it. But almost immediately, drivers noticed something strange. Whenever the wind blew, the bridge didn't simply move, it danced. Cars bounced up and down. The roadway twisted like a ribbon. Locals even gave it a nickname, Galloping Gertie. Engineers believed the movement wasn't dangerous. After all, bridges are supposed to flex. Everything was under control, or so they thought. Then, November 7th, 1940. Wind speeds reached only about 40 miles per hour. Not a hurricane, not a tornado, just an ordinary windy day. Yet, something extraordinary began to happen. The bridge started oscillating violently. Each movement became larger. Each twist became stronger. Steel cables screamed under enormous stress. Concrete cracked. Drivers abandoned their vehicles and ran for their lives. One car remained stranded near the center. Inside, a frightened dog refused to leave. Minutes later, the impossible happened. The entire bridge tore itself apart, not because the wind was exceptionally strong, but because engineers had underestimated one invisible force: aerodynamic resonance. The wind and the bridge synchronized perfectly. Every gust amplified the next, until the structure literally destroyed itself. Millions of dollars vanished into the river below, but something even more valuable was gained: a lesson. Every bridge built afterward would forever change because of Galloping Gertie. Engineers around the world rewrote the rules of bridge design. Wind tunnel testing became standard. Aerodynamic analysis became essential. One collapse changed engineering forever. But astonishingly, the next disaster happened inside a building that people trusted with their lives, and no one saw it coming. Number 4. The hotel that collapsed during a party, Kansas City, July 17, 1981. More than 1,500 people filled the Hyatt Regency Hotel. Music echoed through the enormous atrium. Couples danced beneath elegant suspended walkways. Children laughed. Families celebrated. Everything appeared perfect. Above them, 3 massive suspended walkways overlooked the lobby. Beautiful, modern, safe. Or at least, everyone believed they were. At exactly 7:05 p.m., a loud metallic crack echoed through the building. Most people ignored it. Seconds later, another sound, much louder. Then, without warning, 2 of the suspended walkways collapsed. Thousands of tons of steel and concrete crashed into the crowded lobby below. The elegant ballroom instantly became a nightmare. Dust filled the air. Lights went out. Screams echoed through the hotel. Rescue workers rushed into the debris, not knowing whether the remaining structure would collapse as well. By the time the rescue operation ended, 114 people had lost their lives. More than 200 others were injured. It remains one of the deadliest structural failures in American history. Investigators discovered something almost impossible to believe. The disaster wasn't caused by poor materials. It wasn't caused by an earthquake. It wasn't caused by terrorism. It happened because of one small design change made during construction. A connection that should have supported one walkway was quietly modified to support 2. That single decision doubled the load on critical steel rods. No one realized the danger until it was too late. One drawing, one approval, one overlooked calculation, and more than 100 lives were lost. Engineering isn't only about building incredible structures. Sometimes it's about understanding that even the smallest shortcut can become the biggest disaster. Number 3. The reactor that was never supposed to explode April 26, 1986. 1:23 a.m. Inside reactor number 4 at the Chernobyl nuclear power plant. Engineers were preparing for what should have been a routine safety test. The purpose was simple. They wanted to know whether the reactor's turbines could continue generating electricity for a few seconds after a power outage. A standard engineering procedure. Nothing extraordinary, nothing dangerous, or so everyone believed. As the test began, something unexpected happened. Power levels dropped far lower than planned. Instead of stopping the test, operators tried to recover the reactor. Control rods were withdrawn. Safety systems were disabled. Warning alarms appeared, one after another, yet the test continued. Then, at exactly 1:23:40 a.m., the reactor suddenly surged with power. In less than a second, its output multiplied beyond anything the engineers could control. Steam pressure exploded inside the core. A massive blast ripped through the reactor building. Moments later, a second explosion sent radioactive material high into the atmosphere. The reactor was gone. But what shocked investigators even more was what they discovered afterward. Human error played a role, but it wasn't the whole story. The reactor itself contained a dangerous design flaw. Under certain operating conditions, instead of reducing the nuclear reaction, its design could actually make the reaction stronger. A safety system could briefly increase power instead of reducing it. It was a flaw almost nobody believed could ever become catastrophic. Until it did. Entire cities were evacuated. Hundreds of thousands of people abandoned their homes forever. A radioactive cloud spread across Europe. The exclusion zone remains largely uninhabitable even decades later. The financial cost reached hundreds of billions of dollars. The human cost can never truly be measured. One reactor, one flawed design, one night. History changed forever. But even that wasn't the strangest engineering failure, because the next disaster happened, nearly 225 million kilometers away. Number 2. The spacecraft lost because of one simple mistake, September 23, 1999. After years of development, NASA's Mars Climate Orbiter approached Mars. The spacecraft had traveled millions of kilometers through deep space. Everything appeared perfect. Scientists waited eagerly. This mission would study the Martian atmosphere and provide valuable data for future exploration. Years of work, thousands of engineers, countless calculations, all leading to this moment. Then, without warning, communication stopped. Silence. The spacecraft never entered the correct orbit. Instead, it descended far too low into the Martian atmosphere. Within minutes, the mission was over. NASA had lost an entire spacecraft. What caused the failure? Not a software crash, not an engine malfunction, not a hardware defect, something far more unbelievable. One engineering team used imperial units, another used metric units. One calculated force using pound seconds. The navigation software expected Newton seconds. No automatic system detected the mismatch. No final verification caught the error. A tiny difference in measurement created a massive error in navigation. By the time anyone realized what had happened, the spacecraft was already lost. One of the world's most advanced space agencies, defeated by a unit conversion. The loss was estimated at around $125 million. But the lesson was priceless. Today, engineers across the world study this mission as one of history's greatest reminders. Technology doesn't usually fail because machines stop working. It fails when humans assume everything is correct. And yet, the biggest engineering failure on this list didn't happen in space. It didn't happen inside a nuclear reactor. It happened in the heart of one of America's richest cities. A skyscraper that still stands today, slowly sinking into the ground. The skyscraper that is slowly sinking San Francisco, one of the most expensive cities on Earth. In 2009, construction began on what would become one of the city's most luxurious residential towers, the Millennium Tower, a symbol of modern engineering, luxury, innovation, success. Standing over 58 stories tall, it offered breathtaking views of the San Francisco skyline. Apartments sold for millions of dollars. Business leaders, celebrities, professional athletes. Everyone wanted to live there. When the building officially opened, it was considered an engineering masterpiece. Then, residents noticed something strange. Doors no longer closed properly. Windows began to crack. Floors no longer felt perfectly level. At first, people assumed the building was simply settling, a normal process in large construction projects. But engineers soon discovered something alarming. The tower wasn't just settling, it was sinking, year after year. The building continued moving downward. Even more worrying, it also began to lean, not by a few millimeters, but by several inches, then more. Investigations revealed that the building's foundation had not reached the bedrock beneath the city. Instead, much of the enormous weight rested on dense layers of soil. As the years passed, the ground slowly compressed. The entire skyscraper continued sinking. Billions of dollars in real estate suddenly faced an uncertain future. Lawsuits followed. Experts debated possible solutions. Massive engineering projects were launched in an attempt to stabilize the tower. Even today, the story isn't completely over. The Millennium Tower still stands, but it serves as a powerful reminder that even the most beautiful buildings can hide invisible weaknesses beneath their foundations. Every disaster you've seen today started differently. One bridge, one hotel, one reactor, one spacecraft, one skyscraper. Different countries, different decades, different engineers, but they all shared one thing. None of them was supposed to fail. Every project was designed by intelligent people, reviewed by experts, approved by professionals, built using the best knowledge available at the time. Yet, one overlooked detail, one assumption, one shortcut, one tiny calculation was enough to change history. Engineering is often described as the science of precision, but history teaches us something even more important. Engineering is also the science of humility. Because nature, physics, time, and gravity never forgive mistakes, not even small ones. Every bridge you cross, every airplane you board, every tunnel, every skyscraper exists because thousands of engineers learned from failures like these. Many of the safety standards protecting our lives today were written in the aftermath of tragedy. Those lessons were expensive. Some cost millions, some cost billions, and some were paid for with human lives. The greatest engineering failures in history weren't simply disasters. They became lessons that shaped the modern world. Without them, many of today's buildings, aircraft, bridges, and spacecraft would never have become as safe as they are now. So the next time you walk across a bridge, step inside a skyscraper, or board an airplane, remember this. Behind every successful engineering masterpiece are countless failures that taught humanity how to build better. Thank you for watching. If you enjoyed this documentary, don't forget to like, subscribe, and turn on notifications. Because in the next episode, we'll uncover the most expensive engineering projects that ended in disaster. And trust us, some of them cost more than entire countries. See you in the next documentary.